Hello viewers, in this class we are going to look at similarity and congruency of triangles. What do you mean by similar triangles? What do you mean by congruence triangles? First we'll look at congruence, then we'll come back to similarity of triangles. When I say congruence, in all respects two figures, not only triangles, be it rectangle or a square, in all respects they must be equal. Suppose taking a triangle here, I'm just taking it and just copy pasting it. In all respects these two triangles are congruent. Okay, so when I'm saying congruence of triangles, two triangles must be equal in their shape and as well as in size. So two things that must be remembered. They must be equal in shape and as well as in size. It can be any figure, not only triangles. If any two figures if you take, they must be equal in shape and size, then you say that they are congruent. Just take a figure. I'm just taking a triangle, side 1, side 2, side 3. I'm just tilting or rotating this triangle. Now, by looking at this side 1, side 2, side 3, we can say these two triangles are equal in shape and as well as in size. I may not be exactly giving them, but I am rotating it and giving it. In any pattern doesn't matter, but all you must remember is they must be equal in shape and as well as in size. So you call it congruency of triangles. Now how do you recognize two triangles are congruent triangles? So we say conditions for congruency. All three sides of one triangle, side, 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 all three sides of one triangle must be equal to all three sides of a second triangle. Then you say they are congruent triangles. Second, two sides and corresponding angle. Two sides and corresponding angle. The first one, if you know that these three sides of one triangle is equals to three sides of another triangle, we say that it is congruent. Otherwise, you know two sides and one angle between them. If it is theta, side 1, side 2. Same thing. You know two sides and one angle. Then we say SAS. Third one, right angle, hypotenuse on one side. This is in case of a right angle triangle. You know that one angle is right angle. You know one side, this side and right angle. So obviously the third side is automatically equal. So if they are same, side, right angle and hypotenuse, this is hypotenuse, it's a right angle. So out of these three, the first one, all three sides of one triangle is equals to the all three sides of another triangle, then they are equal. The second one, two sides and their respective angle should be equal. Suppose this angle is theta, side 1, side 2. Another one, side 1, side 3, angle between them is theta. Here two sides are equal, their respective angle is not equal. This is in between 1 and 2, this is in between 1 and 3. So here I want this angle to be equal to theta, not the angle which is in between 1 and 3. So make sure the corresponding or the respective angle must be equal in case of SAS. So RHS, R means right angle, H means hypotenuse, S means any one of the side. If you know one side, for example 3, 4, 5. You know side 5, side 3, by using this right angle we can say it is a right angle triangle. So I am giving you two right angle triangles with side 3 and hypotenuse 5. Therefore the other side in both the triangles will be 4 only, which means all three sides are equal only. So by using these three conditions we can say two triangles are congruent triangles. What happens if two triangles are congruent triangles? We say CPCT. Corresponding parts of congruent triangles. are equal. If you know that two triangles are congruent, their corresponding parts are equal. What do you mean by corresponding parts of a congruent triangle? Suppose, just take a triangle. I am saying the first triangle is triangle ABC. Second triangle is PQR. We know that AB is equals to PQ, AC is equals to PR, BC is equals to QR. So I would say triangle ABC is congruent to, this symbol represents the congruency, triangle PQR. What do you know that if they are congruent? Suppose they are congruent. What do we know from this? Keep it aside. Remember that if they are congruent, their sides are equal. AB is equals to PQ and so on. All sides are equal. Not only sides, their areas are equal. Area 1 is equals to area 2. Their heights of their triangles are equal. Height 1 is equals to height 2. Their perimeters are also equal. Perimeter 1 is equals to perimeter 2. In all respects, these two triangles are equal. Suppose you know congruency of triangle by using this angle theta. Then what about this angle? This angle will also be theta. Suppose if this angle C is 50 degrees, then I'll ask you, what is angle R? Angle R will also be 50 degrees. How do I know that? By using CPCT. What do you mean by CPCT? Corresponding parts of congruence triangles. So you can find out the unknown triangle when you know that they are congruent. So mostly we use congruence triangles in proving something. Now very important thing is similarity of triangle. What is the difference between similarity and congruency of triangle? When I say congruent triangles, two triangles must be equal in their shape and as well as in size. But for similarity of triangles, two triangles must be equal in shape. So two triangles must be equal in shape. Forget about sizes. We don't care about sizes in case of similarity, but they should be equal in shape. See here, I'm just drawing a random triangle. Let's say 1, this is just a random triangle. Taking the same triangle here. See, I magnified this triangle, but I have not changed the shape of the triangle. Let's say triangle 1, triangle 2, triangle 3. Triangle 1 and triangle 2, I have not even changed. I have not even changed the size of the triangle. So triangle 1 and triangle 2 is what? Congruency of triangle. Now for these two, triangle 3 is similar. This symbol represents only similar. Equal to symbol along with that symbol gives you congruency of triangles. Now here triangle 1 and triangle 2, both of them are equal in size and shape, therefore they are congruent. Third one is not equal in shape, so it is similar. Now how do you identify two similar triangles? Again you have some conditions. Conditions for similarity. First condition, angle, 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 or else two angles. Conditions for similarity, 3 angles, 2 angles. The first one is 3 angles or 2 angles. All the 3 angles of the first one should be all the 3 angles of the second one. Or else you can say at least 2 angles of the first triangle is equal to 2 angles of the other triangle. If not 3, at least 2 angles must be equal. If you don't know the third angle also not a problem, because if it is 50, this is 70. In the other triangle also you know that it is 50 and 70. Obviously what is the third angle in the first one? 60. What is the third angle in the second one? 60. So even if you know 2 angles or else 3 angles, it's okay. So the first one is angle, 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 or else 2 angles. The second condition, side, angle, side. side should be in proportion and angle should be equal. I mean to say, if I take this to ABC PQR, AB by PQ, proportion means their ratio must be equal, AC by PR, and angle A should be equal to angle P. The third one is triplus. Again I am saying side should be proportional. All three sides of the first should be proportional to all three sides of the second. What happens when two triangles are similar to each other? Just taking two similar triangles. We are just taking ABC PQR, and I am saying triangle ABC is similar to triangle PQR. If triangle ABC is similar to PQR, we can say AB by PQ is equals to BC by QR. Corresponding sides only you should take. AC by PR, which is equals to their heights. H1 is the first triangle, H2 is the second triangle. Their perimeter should also be equal. All these ratios is equals to K, which means they are same. When it comes to their areas, area of the first triangle by area of the second triangle, area is half into base into height, generally base 1 into height 1, half into base 2 into height 2. 1 by 2 anyway gets cancelled. Therefore, you will get B1 by B2 into H1 by H2. They are always their proportion, okay, their ratio is equals to K I have taken. So, K into K, K square, which means the ratio of the areas of the similar triangles is equals to square of the ratio of their sides, AB by PQ you can take it, or else you can take BC by QR whole square, or else AC by PR whole square, or else H1 by H2. If you know their heights, you can take their heights, ratio of their heights and square it. If you know their perimeter ratio, then square of this is equals to ratio of their areas. I have taken two similar triangles. These triangles are similar, ABC PQR. Suppose angle A is equals to angle P, but angle B is equals to angle R, and angle C is equals to angle Q. Here triangle ABC is not similar to PQR. In fact, the triangle ABC is similar to what? ABC is similar to angle P. B is same as R, therefore PRQ. Now we say AB by PR, BC by RQ, AC by PQ. Like this we say area 1 by area 2 is equals to any of these sides ratio whole square. That is how we proceed. Two triangles. Suppose triangle 1, triangle 2. These are similar triangles I am giving you. This side is 6, this side is 12. They are similar triangles in the respective ratio. If this side is 7, if it is x, find out the value of x. ABC PQR. And I am giving you ABC is similar to triangle PQR. What you can take it? 6 by 12 is equals to 7 by x. Therefore, x is equals to 14. See here, normally if 6 becomes double 12, 7 becomes double 14. Suppose area 1 is equals to 10, then what is area 2? Their sides ratio is 1:2, means their areas ratio will be 1:4. Remember, or else if you look at by formula, area 1 by area 2 is equals to side 1 by side 2 whole square. 6 by 12 any known sides you take it and square it. So area 1 is 10 by area 2 is equals to 1 by 2 whole square is 1 by 4. Area 2 is equals to 40. I'm just giving you random values as areas. Area is equals to 10 and 40. These are random values here. So here you can observe the sides ratio is 1:2. Therefore, areas ratio is 1:4. Similarity may or may not happen in two different triangles. It can happen within the single triangle also, and it is very, very important. Now, the most frequently asked questions are like in a single triangle. The moment you know, I am taking the triangle ABC, I have taken 2 points D and E. D and E are the 2 points on the sides AB and AC respectively. DE is parallel to BC. Remember, if DE, the moment DE is parallel to BC. Yesterday we have seen about angles. These are corresponding angles. Angle B is equals to angle D. In the same manner, angle E is equals to angle E. And angle A is common to both. Angle A is common to both. This is angle A is common angle for both the triangles. Here, what are the triangles that I am referring to? Triangle ADE similar to triangle ABC. Therefore, their ratios again the same. AD by AB is equals to DE by BC. It goes on same way. AE by AC is equals to their heights and their areas and so on like that. Now, here one thing you have to carefully observe is, if I say AD is equals to 3, DB is equals to 9. AD is equals to 3, DB is equals to 9. If DE is equals to 5, BC is equals to how much? I am asking you to find the value of x. In order to find the value of x, now look at here, AD becoming DB, 3 becomes 9. If you normally take it, 3 becomes 9, it is incorrect. 3 into 3 is 9. But here you have to look at the side AD to the side AB, which means 3 becomes 12, not 9. So, the similarity says AD by AB is equals to 5 by x. So, 3 becomes 12, that is 4 times, therefore 5 becomes 20. X is equals to 20. And their areas are also very, very important. Area of triangle ADE by area of triangle ABC is equals to, take any side, AD by AB whole square. Sometimes they will ask you the area of quadrilateral triangle ADE by area of quadrilateral BCDE or else BCED. So, how do you find it? AD square by, see, this is area 1, this is area 2. So, from the whole triangle you just need to subtract area 1. Therefore, from the whole AB square you must subtract AD square. Let me give it with an example so that you can understand better. The moment you say DE is parallel to BC, we know the triangle ADE is similar to triangle ABC, and I am giving AD is to ABD is 2:3. Find area of triangle ADE, area of quadrilateral BCED, quadrilateral or trapezium. Now see, area 1, area 2. Assume that this is area 1, this is area 2. Now as we know, area 1 is a smaller triangle, area 2 is a quadrilateral. So what is the bigger triangle area? The whole triangle area ABC, triangle ABC becomes area 1 plus area 2. So small triangle is area 1, bigger triangle is area 1 plus area 2. Ratio of their areas, ratio of their sides, if it is 2 is to, this is 2 and this is 3, AD is to AB becomes, AD is to AB becomes 2 is to 5. So this is 2 by 5 whole square. Now area 1 by area 1 plus area 2 is equals to 4 by 25. But I am looking for area 1 by area 2. So this is 4 parts. Out of 25 parts you take out 4 parts. It becomes 21. So far we have seen the properties of congruency and the similarity of triangles. What happens when a triangles are congruent and similar? How do we find out the missing sides and the areas of perimeter or heights? How can a similarity happens in two different triangles or else within a single triangle? So how do we find out the ratio of different areas of a triangle? So in the next class, we are going to learn the applications of similarities. Until then, thank you.